Thanks, Jeff. Thanks, Marcio. Love doing these events with you guys. It's been a lot of fun. There's been a lot of great conversations about all the different types of solutions that we have available. As Jeff said, my name is Jason Sand. I'm Director of Sales and Business Development for Elkane Associates, and we're a manufacturer's rep firm for the state of Florida. We represent multiple brands of technology solutions, many of which are found in your clients' homes. And we work with companies like Boca to help specify and design our products into their projects. And so today's course we're talking about is Introduction to Microgrids. And this is a really interesting one. We've spent a lot of time over the past few months talking about lighting control and shades and numerous other topics that most of us have probably heard of. But microgrids is something new. And so I'm pretty excited to present this. This is presented by Savant and RacePoint Energy. There are two sister companies that manufacture automation as well as energy solutions, many of which that you're going to see today. As Jeff pointed out, members of AIA will be receiving credits for this, so Marcio and myself will follow up on how to earn those credits after attending the course. So what we're going to talk about, we're going to focus on helping everyone understand the evolving energy landscape and the impact on the home ownership experience. Solar panels have been around for a very long time. They've evolved tremendously, and now we have other technologies being introduced in battery and storage and other applications. So we're going to talk about that. We're going to talk about the value of incorporating microgrids into your property designs. Houses being built always follow an evolution. In the interior, stainless and granite were options, right? Now they're standards, and those standards are always changing. I work with a lot of home builders who put generators as a standard in their design. So this is another solution that as architects or designers, you might want to think about as adding into your designs to then add more value. We're going to help you become familiar with the main components and functionality of a microgrid. We're going to explain what a microgrid is and all the different components. And then we're going to talk about what critical data is required if you're looking to get something designed. And I actually have some examples of specific size houses and client requirements and what a cost of a microgrid is to give you some examples. First, let's talk about the changing market. So we all live in Florida, and Florida, as well as California, Jeff and I were talking about this prior to the call, really have issues with power. We're like the lightning capital of the world. California is home to rolling blackouts as well as fires, which is another situation. But the bottom line is the grid infrastructure is continuing to erode. To give you an example of mine, I live in Plantation, Florida. A couple years ago before Wilma, we had multiple power outages just during the day at random. And FP&L pretty much told me there was nothing they could do. And I used a device that could monitor the power fluctuations, and it really determined that there was an actual issue. Before I could show that to an FP&L, we had Hurricane Wilma come through, knocked out power for a few days. But when power was restored to Broward County, my issues went away. And that's because they had to replace part of the infrastructure. I was involved in a similar situation in California where a client had a year's worth of power issues. And after putting some devices in to monitor it, the power company came out and replaced 3 transformers outside their house. So what that's telling you is they're not actively upgrading the grid. As you can see here, it's about $7 trillion to modernize the infrastructure. So they only replace things when they're broken. In some cases, they're broken as long as it's not causing a fire. It could be causing power issues. They're not going to fix it. By the way, at least with FP&L, but I think it's with most utilities, they're only under contract to give you 10% of 120 volts, which means between 108 and 132 volts is perfectly acceptable. That's not acceptable in our homes. That power fluctuation can wreak havoc on our electronics, cause lots of light flickering, but that's all they're under contract for. So what's happening in the power space is pretty alarming. The way power is generated and managed has changed a lot. Battery costs have come down. We see them now in electric cars. Solar panel costs have come down. So that's another thing that's changing. And homeowners are now seeking energy independence, right? They want to be off the grid 100%. So that's where a microgrid comes into play. And lastly, there's 3 main motivators. There's energy resilience, there's the economic factor, and then of course there's the environmental factor. all three which we're going to talk about. So when we get into the microgrid, essentially it's your own power plant. For years, we have islands down here in the Caribbean, the Bahamas, that have their own little microgrids. They have generators and solar panels and battery systems to keep those areas running. And so you have a couple of components. You have the utility grid, which is your source of power. You have local energy creation, which is your local solar panels, which is also creating power. And then you have to have some sort of storage system. What many people don't realize is that when you have solar on your house, if you do not have storage, the solar doesn't work when your power goes out. And I'll repeat that again. If you have solar installed at your house and you don't have a way to store it, when power goes out, you cannot use the solar panels. That's something I learned at an energy workshop last year. And I think most customers just kind of assume, well, if power goes out and it's the middle of the day, I got my solar panels. Not unless you have storage, because the power companies don't want that power being generated to go back into the grid. So they don't allow it. If you have storage, all that overproduction from your sun and your solar panels can be stored to be used later. It's a critical component. So storage and an inverter, and then also you have a generator. That's another way of generating power. All of these things can be adjusted based on the design goals of the client. They may not want a generator because they're environmentally conscious, and so we can remove that component that shifts the design of the other two components. So all this feeds your house, which then feeds all your devices in the house, from home automation to monitoring the energy, things we're going to get into a little bit later. So why would you invest in a microgrid? So we talked about energy resilience. Clients want to seek energy independence, right? And that comes from avoiding power outages, avoiding rolling blackouts. And I had an outage in my house this week for about 10 minutes. We didn't know how long it was going to last at the time. We're working from home. So just not having to be reliant on the grid is becoming a bigger issue because the grid is so poor and we can't control it. Over in California, they have rolling blackouts. Now with all the fires, they're actually shutting power off in advance to stop the spread of the fire. So you have no control over your power. Also, peace of mind is a big issue. Again, not having to worry about if power goes out, you have to walk around and reset all those clocks, or you don't know how long it's going to be out for. We're now all working from home. So having that peace of mind is a big factor. Security is another one. If you lose power and you have electric door locks and cameras and alarm systems, none of those will continue to work. So having power available when you don't is a big deal. And then last, comfort, right? Being able to run your HVAC system and any other creature comforts in your house. You have power all the time. You don't have to worry about that. From an economic savings, the cost of solar and storage has come down greatly. And so that's helped bring the cost of these systems down. Also, you can capitalize on varied rate structures. I'm not too in tune with how they do it in with FP&L, but I know like in California, from like afternoon to 5 and 5 to 9 p.m., the rates skyrocket because the usage is more. So if you have a microgrid system, you can use it when the rates are higher, which again, we call that peak rate or time of use. So that allows you to save money versus paying the higher rates. There's a lot of state and federal incentives, and I'll show you some examples of those discounts when we do some examples with the quotes. And then, of course, if you're running a microgrid, you're no longer paying your utility bills, so that's an additional savings. I will tell you, to try and do an actual ROI calculation can be a little difficult. These systems are still not inexpensive. When we're talking about a full-on microgrid, just doing solar, you can calculate ROI as it's a lower investment. It does take a longer time. But we'll show you some of these savings and calculations a little bit later. So the other factor is the environmental impact, right? People want to be green. They want to save the planet. They're looking to have a net zero certification for their property. Maybe they just want to eliminate excess use of energy. Remember, the power companies pumping power into the grid, not really knowing how much is going to be used, which then creates a bunch of waste. So by being independent, we can help fight that battle. And then overall, help reduce our carbon footprint. So when we look at a microgrid operation, this kind of gives you a snapshot. You have your utility grid, which feeds your transfer switch, and it's an automatic transfer switch. So when power goes out, it automatically switches over to your system, which consists of some sort of battery or storage solution. You're going to have a solar component as part of that. and that's going to feed into what we call a flexible load management system. So your breakers that are installed in the house, which is what connects everything to power from your main, are not controllable. This flexible load management system allows us to control those. So that helps us do a lot of things, which I'll show you later, where we can create scenes. So imagine a storm is coming, right? Within a day or so, we can hit a button that preps the system to make sure the batteries are topped off from the solar panels to prepare for a long-term outage. And that's only being able to be done with this type of flexible load management system. So here the grid turns off, and now our system is running all of these different critical loads in the house. So time of use benefits. So I mentioned this earlier. So again, every state varies, but this is an example that typically off-peak hours when there's not a lot of demand for energy, the rates are lower. But in the time that there is a bigger demand, afternoon and evening, a lot of those companies will double or triple their rates. There's also sometimes usage rate hikes. So the owner of Race Point Energy has a house up in Boston, and if he exceeds a certain amount of usage in a month, his rates triple. So with this system, it's programmed that if they before they hit that rate amount, the system can be programmed to pull off the grid and just use their microgrid until the month cycle is over. So there's time of use, but there's also peak rate usages, which is interesting. Again, it varies by state. But having this microgrid allows us to augment this so that we're saving money and not paying these higher rates during the time of use. So looking further about engineering a system, so these microgrids consist of some sort of home controller, and in this solution we're using a Mac Mini software computer with some additional software on there to control all these devices. So we're able to monitor and control the solar array system, the energy storage system, as well as the load management system. And so with these three components, we can control this microgrid and allow things to shift back and forth throughout the day. Imagine that our batteries were low and needed charging. The system can then know that, well, the rates are really high from the grid right now, so why don't we pull from solar because it's 1 o'clock in the afternoon and we can use the solar to then charge the battery versus pulling from the grid. This all happens by having this automation system of your microgrid, which is really, really interesting and fascinating. So when we talk about energy, there's a couple terms we should be familiar with. We have power, which is the maximum amount of electrical power that can be delivered through the inverter. And again, when you submit a design request, these are things we ask as far as how much power the house has or how much power is it going to pull. We have to design the right inverter. This is all measured in kilowatts or kWs. So if something is able to charge up 20 kWs over 5 hours, it's going to equal about 100 kWs of power for the house. And for large homes, 10, 20, 30,000 square foot homes, 100 kW is not out of the realm of need for those types of projects when you're talking about air conditioning and basically putting everything on the system. So traditional solar, solar consists of either ground mount. So we've had projects where they have acres and acres of land, and we can actually put solar array fields out in the field versus on the house. We can do rooftop, and we can do carport installations. But the key here is to properly design the solar field based on the goals of the client to achieve maximum efficiency. And when these systems get designed, the team has to look at the house. They go to Google Maps and check out the view. They look at where the sun rises, where the sun sets, and can design a solar array system for maximum efficiency. And again, based on the needs of the client. Do they want to be off the grid 100%? Are they looking for just some grid autonomy so they're not reliant on it? And everything gets designed around that. And again, it's only best used when it's paired with storage. If you just put a solar system on your house, yes, it is going to help you save some money, but you're still wasting money. If this overproduces or produces more power than what your house needs, it doesn't go back into the grid, it just gets wasted. In some states, they do allow power to go back into the grid, and they do pay you some money for that, but all of that varies from state to state. So these solar systems that get designed, again, they can be designed in different size arrays. This example here is a 15 kW array. So this is able to produce 15 kilowatts of power. It's a roof mount installation. And the estimated daily energy production is 57 kilowatts of power. Again, if we know what the project requirement is, we can then determine if this is going to be the proper solution. But also, too, is we want to be able to store that power so we can use it at different dates. Use it in the evening when there's no sun, or use it in those high peak, high demand times, so we're not paying those higher rates. So the other part of the solution is a whole home battery backup. Now, anyone that's been involved in a project using audio, video, and electronics has probably heard of a UPS or a battery backup. And again, those are solutions so that when there's no power, you have power. So typically they're used for computers so that they don't, just shut off at random, which can cause damage, or you can lose files. But these battery backup systems have been starting to be used on almost everything with audio video. Think of it this way: almost everything we plug into power in our house is now connecting to our internet, whether it's wireless or wired. That means there's microprocessors installed in these products, which means they're more sensitive to voltage fluctuations. So earlier I mentioned that the voltage is going to fluctuate between 108 and 132 volts, and there's nothing you can do about it. Putting in some sort of energy whole home backup is going to keep that consistent, keep that fluctuation from happening, which again is going to keep electronics online, keep lights from flickering, and then protect you from using the grid. So that grid independence, or that grid autonomy. So this is going to store the energy that's being produced by the solar array that gets put into the house. So that means the house has always remained powered, and you can use that energy on demand during those peak shaving times when power's out. Maybe there's a storm coming. If you're in California and there's a fire coming, you can disconnect from the grid and then just basically run on your own. This also helps you maximize your solar system, because we're no longer overproducing and wasting that energy or putting it back into the grid. We're able to save it for a later date. So some examples of specs. So typically the battery technology is lithium ion. That's the latest and greatest in technology. The big benefit to what we're showing you here is these are single phase or three phase. These are designed for large projects or possibly islands. We've had projects where clients own an island and there's no energy production on that island, so they have to put some sort of microgrid solution in. A lot of times it's just solar and generator. So the solar runs the house during the day and the generator kicks on at night, which is kind of noisy. So this is a much better solution. Also, the other products on the market like Sonnen and Tesla Powerwalls cannot scale to these larger sizes. They can't do three phase. They can't go, I think it's over 40 or 50 kW. There's some other limitations. So again, since we primarily work on really large square footprint homes, this is a better design solution. You have a lot more flexibility. As you see, we can go from a 60 kW all the way up to a 204 kW. Couple things to note: this enclosure you're looking at is something that has to go outside, goes on a concrete pad, but is a full NEMA certified enclosure. It's built with a fire suppression system. It's outdoor rated. It's designed for those elements. Depending on the structure, we have designed these to go inside of the house as well. It is a battery system, so it's not really generating any noise like you find with a generator. So some of the design values of having the storage. So the inverter is the energy pipeline to the home. Earlier you saw the grid, you saw the energy storage, and then that was tied to the inverter, which is your pipeline home. It needs to be sufficient to meet the off-grid needs of the home. So if the home needs a 50 kW worth of power, we need to make sure the inverter is spec'd properly. This is going to help you reduce your carbon footprint. You're saving on electrons. What you produce from solar, you're able to use at a later date. Nothing's getting wasted. And this is all engineered to provide the home power for a single storage platform. So whether they want to be off the grid 100% or they want a system to help augment the grid and not have to rely on it, so a little bit of an outage, there's no stress because you have power as a backup, this is a really great solution. A lot of people use generators for that, but generators take 15 to 20 minutes to turn on and ramp up. They also provide very dirty power. So this is a much better solution. So earlier I talked about flexible load management, which is another key component. And these are essentially companion modules that look much like a breaker and go in an electrical panel. And critical loads are flowing through these circuits. This is giving us a few options. It's allowing us to monitor the energy of the house, the energy usage, all the way down to the load. And we can also control those loads. So I'll give you some examples of those benefits, but imagine being able to see what areas of the house are using more energy than others, and now shutting those circuits off during certain times based on either an outage or just based on you wanting to save energy. So there's a lot of really neat things that we can do with this flexible load management. Going outside of a microgrid, right now a lot of projects are almost always consisting of a generator. You could just install this flexible load management system as a way to automate your dedicated load panel. So the dedicated load panel is something that's always very tough for a client to decide on when they're building the house. So instead of telling them they have to pick 20 dedicated load circuits, you could actually give them more with this flexible load management. And then the system can be programmed to never have more demand than what's needed, but you can adjust things on the fly. So for example, the air conditioning system is almost always considered part of the critical load panel. Well, if you look at a day like today, if our power goes out, I probably don't need air conditioning. But if we had a static traditional panel, we can't just shut that air conditioning off and use that power for something else. With the flexible load management system, we can do that. So identifying critical loads. Again, when you're going into this design, if you were looking at a generator solution, these are typically the critical loads that get chosen for that generator. But by having a flexible load management system, we can choose these in addition to others that we feel we would want to use in the event of an outage. And so we can have other luxuries on the system with this flexible load management that aren't required to be a part of it. We can use them if we want to. So again, everything is automated on the fly. So depending on the situation you're dealing with, you could have an energy savings mode, you could have a hurricane prep mode, but everything is adjustable on the fly by using this flexible load management system. And it extends the life of your stored energy because it's not just, I have this much power, I have these critical loads, that's what I'm going to use. You can adjust things how you want to. So I kept talking about modes or these scenes. So this is a couple of examples of the power of the system. You know, you could have a money saver mode, which automatically adjusts the certain loads to use and prioritizes them during that peak time of use. So if you are stuck on the grid, you can prioritize what load you want to use, and that could be a money saver mode, and that's just at a push of a button, your house is shifting into that mode. You could have an island mode, which disconnects you from the grid. So you have complete grid independence. And part of that island mode could be, I'm going to engage island mode. Oh, my batteries aren't topped off. Well, it's 1 o'clock in the afternoon, so let's top off those batteries and then disconnect from the grid. This all happens automatically. You could have a storm mode, which again proactively prepares the home for an impending grid loss. So it prioritizes battery storage and charging of the batteries based on what's programmed into the system. And then you can have another mode called critical load. So again, this could be like the absolute must loads that have to be powered in the house. Maybe that's a camera system, security, a few lights, and your refrigerator and AC. Again, these are just examples, but with this solution, there are endless possibilities. So this kind of gives you an example of how everything works together. You know, you plan what it is you want to do. We can create these modes for you. You act using, automated HVAC systems, which helps further save energy, and LED lighting systems, which also help save energy. Track everything through this flexible load management. It's giving you real-time reporting of energy usage, and then you can react to do it. You're doing full energy management with the solution. A lot of times people confuse energy monitoring with management. Energy monitoring is just seeing what's happening. Management gives you the ability to react. So with this system, you can react to your usage. So here's some shots of the dashboard you get to see, which is in our app or in our iPad. But you can see total energy consumption. You can also filter that based on areas of the house or however the system's set up. So you can see on one of those screens, you see the total energy consumption, and you can see it broken down by the pool, larger appliances. And then lastly, you can see the different modes that can be configured to deploy the system. So applications. So again, here are your main components of a full-on microgrid. So you have your whole home battery backup. This is your storage solution. Again, this gets designed based on what the client's goals and objectives are and the size of the house. You could have something called a critical load backup. So a whole home backup typically is so large it has to go outside. And by large, it's pretty on par with what a large generator would be. But there are smaller solutions that can go inside the house, like this one here for the critical load backup, and that's just used for those critical loads that we need. And then we have the flexible load management. This is a system that layers on top of your current breaker system, but this gives us that option of adjusting loads on the fly, further saving you energy, but also giving you that ultimate flexibility. And then we have various ways to monitor energy as well. So for products that produce a lot more power or draw a lot more current, we have other types of energy monitoring devices so we can track and see what's happening. And then of course, the solar design and installation of the system, which goes hand in hand with the rest of the products. So I talked about this a little bit earlier, so I want to go back. Full-on microgrid is the ultimate solution. It's basically a power plant for your home. However, it's not always feasible, and I'm going to take you through some use cases to show you some rough cost breakdowns. But in the event you want to offer some sort of similar solution, we can do what we call flexible load management. So again, most clients are putting generators on their homes, and it's basically wired that when power goes out, it ties to the critical load panel, and those are the loads they get to use, and there's no change in it after that. By using a flexible load management system, there is no fixed critical load panel. All the loads can be critical based on demand. You could have 50 kilowatts of power available from the generator, but you could have 100 kilowatts of loads available, and the system can be automated to use those loads based on what's available. But the result is you basically are unlimited with your options. And then the generator can be sized a little bit more modestly, again, depending on space, cost, and what the demand is looking for. And we're also improving the efficiency of the generator because we're maximizing the optimal load amount. And this can be done new, this can be done retrofit as well. So essentially what we're doing here is we're replacing your standard critical load panel that you would put in, and we're layering on top of that this flexible load management system. And it's actually pretty cost effective to do. Energy monitoring, and so that's another system that can be done separately from the entire microgrid, is we have energy monitoring systems that can go in and monitor energy usage, and then that allows you to react and act differently based on what your goals and objectives are. So we can look at history data, we can compare solar production to consumption, we can identify ways to conserve energy, we can see if there's a product that's not performing properly, and again, this can be done as a new construction or retrofit application. So to get one of these systems installed or get a quote going, and this is a free of charge service that we offer, but basically if you said, I think my client would be interested in a microgrid, where do I start? We have a simple one-page sheet, and we try to capture the load profile of the home. We want to understand how much power is it going to take to run this house. We also want to understand what the goals and objectives are. If the house is 30,000 square feet and we know it's going to need 100 kW of power and they want to be off the grid all the time, that's going to push the design into one side of it versus if they just wanted some grid autonomy. So this form helps us capture all that information and set those expectations. We can also look at the location of the project and actually give you an estimate for clean energy incentives. So when I show you some examples coming up, you'll actually see when you do these quotes, how much the client's going to save, and show how it's going to support your utility bills, floor plans, electrical, etc. This is just the initial form to establish a budget. Then once we get entered into some sort of engineering contract, all the engineering and drawings are done on our side. So we can put together a preliminary proposal and really show you the value and the benefits. So this shows you a breakdown of an initial system for a client. And so in this case, we're looking at a total cost of this system at about $324,000. The only thing this does not include is the labor for installation, but this is the cost of the solar array. This is a cost for the battery storage system, the flexible load management, basically all the components that I showed you earlier, the inverter. And then you can start to see the savings. So you can see the federal tax incentives, the state incentives, and then we can do some estimates of real time of use estimated savings. So how we're going to save on your electric bill savings over time. So this helps start you down the path of that ROI calculation. So first example would be the empty nesters, a 5,000 square foot home, or maybe it's some sort of dwelling. Basically, they're looking to have extended power. They're concerned about extended power outages. They don't mind reducing power during outages, so they don't mind operating at half capacity. They want to lower their electricity costs, maybe have 8 to 10 hours of autonomy. 8 to 10 hours means for 8 to 10 hours a day, they're not relying on the grid. And they want solar, but they don't want it to have this huge visual impact. So this is not I want to be off the grid 100%. This is I want to be off the grid, maybe half the day, right? And so their key loads are the pool, some fountains, a small AV rack, appliances, HVAC system, etc. So this is kind of the rough breakdown of this type of system. The flexible load management is about $22,000. The energy storage system is about $125,000. That usually dictates a lot of the cost. The solar array, about $38,000, and then we have our incentives. So it nets out to about this $145,000 for this type of house with this type of application. And then we get into the larger house, so 15,000 square foot house with a guest house. They want access to everything during grid outages. Economics is not important. So this is the case where we don't really care about the price. We just want to live in the ultimate comfort. We don't want to have any stress over outages. So 24 hours of autonomy at full load, large solar capability. They want to be able to go off the grid whenever they choose. And then here's their list of their notable loads. And here's where we're at for pricing wise. So that type of system is about $45,000 for the flexible load management, close to $300,000 for the energy storage solution, about $76,000 for the solar array, and then less all the different incentives. And that gives you that kind of budget number. And so when you submit that form that I showed you earlier, this is what you get back. All right. And then we can go and redesign it from there. Client says, wow, that budget's too high. We know, okay, well, have to pull back on some of this grid autonomy because that's what drives the cost up. The more you want to be off the grid, the more the cost is going to go up. It's more batteries, it's more solar. That brings us to the end with questions. I don't know if questions were coming into the chat. Jeff, were there questions coming in?
There wasn't anything coming into the chat, but I do have some things I'd like to do to spur the conversation.
Sure.
I'm going to go ahead and share my screen here. So power quality is a big deal. And one thing I wanted to show you here is we run a microgrid here at BTA. This is a live look at it right now. We have a 16 kW solar array on the roof. 50% of it, 8 kW, is going into this battery system, and the other 8 kW is feeding right into our MDF, which is the big 600 amp service that comes into our building here. This used to be a bank, so we have a 600 amp service in this building. So we run like air conditioners and things like that are all plugged into the MDF, and the solar assists when it can. Here you just see we had some cloud cover, so we were generating 1.29 kW of solar. And the graph on the bottom shows you solar production versus battery usage, what's going into the battery, what's being generated, what's being consumed. So there we go. We just went up to 6.2 kilowatts. So this is a smaller scale system, and it's not of the same category of what Jason is talking about, but it is focused on power quality only for critical loads. And we run our entire showroom, which is all of the computers and the networking and the AV systems here in our showroom, which is a significant load. And you can see that we're somewhere in the nine, this critical load right here where my cursor is. We consume somewhere between 8.5 and 9 kilowatts on the critical load side. So that's not total building, that's just this special stuff. So that's one thing that I wanted to show you. There is also, if anyone's interested at home to understand, well, what kind of energy do we use? There's this really inexpensive product called Sense. Um, I bought one years ago when they were crowdfunded, and this is a live look at my house. So this little box goes inside your electric box, your main circuit breaker panel, and it has like a clamp-on ammeter that monitors the power usage, and the cloud service senses and tries to identify the loads. And it says it's an air conditioner, it's a refrigerator, it's a disposal, electric car, those kinds of things. It can figure that out, and then if you're really motivated, you can go and type in your own names on it. And I did that for some of them. But so I'm using right now 6.7 kilowatts. And yeah, I guess I'm 97% higher than other people. I don't know where it got that statistic. I don't know if I like that or not, but I use power, and I want to measure it. It also tells you your phantom loads. So like I've always had 2 kilowatts running, whatever's in the house, refrigerators and whatever AV TVs are in standby or what have you. So anyway, so I point that out as just something that you might be interested in if you want to figure out what your usage might be and what kind of a load would be important. So power quality is really key to us. And one thing I could also recommend, we are building a unit right now in Aquilina. And one thing you can do is you can isolate your critical loads. And this is what we're doing for this particular client, where we're taking all of the TVs, that's these three, all these little blue things represent TVs in the house. And then the office, where we have these special isolated ground outlets. What this does is establishes a critical load panel. I'm not doing batteries here, I'm not doing anything like that. But if later we had a problem, all I got to do is put these two Surgex units on a battery, and all of my critical loads are already separated out for this client. If you're going to do your entire house and everything in it, you need something along the scale of what Jason was talking about. And that's really important to understand, well, what are we trying to accomplish? Is it everything, or is it just, let me just make sure my sensitive electronics and my office equipment, my network stays live, and, the building has a generator for everything else. So anyway, I wanted to share those two things with you. The critical load thing is important when you're designing. It can be retrofitted. We have retrofitted a number of homes, 5 of them so far, where we've literally crawled through the attic and ran new Romex because of the issues. We found up and down Lyons Road here in West Boca is really bad. The GL Homes, the Oaks, Stone Creek Mansions, Meisner Country Club are probably some of the worst ones. And Jason, your exact story happened to me 3 times, where we fought with FP&L. We got them to come out and measure power, basically proved we were within their spec. Obviously, it's Boca Tech's fault if things don't work, even though we don't produce the power. And then they had a hurricane, and it knocked out their transformer. They get a new transformer, problem solved. But they wouldn't do it otherwise. They would not do it. It was still within spec as far as they were concerned. That has happened multiple times. And I think that most clients don't understand that. They just think that your stuff is broken. But if you start seeing things like steam showers don't work and your AV freezes. Um, this particular client, the smart apps in their TV would lock up and freeze and have to reboot the TV. Those kinds of strange things, it's probably power quality. That's probably your issue, you know?
Absolutely. So there's actually a good question in the chat about having clean power, and the question is, what if someone already has power conditioners in the equipment rack from Panamax or Furman? And I'll give my 2 cents and let you comment, Jeff. But so
Okay.
yeah, for the AV system, so there's 2 things that you have to think about with power, having clean power. Is there's some sort of surge protection which covers the overage, right? So I mentioned the scale is 108 to 132. So everything above 132 is considered a spike that can happen from obviously lightning, but also stuff internally in the house, like your generator, your AC kicks on, your refrigerator kicks on, motors and stuff send spikes down the line. But the brownouts, everything below 108, a surge protector doesn't do anything. And the only way to protect that is making sure your neutral to ground is set up properly, but also a good UPS is going to stay on to keep that voltage from fluctuating. Now, taking a deeper dive into it, different brands like Panamax and Furman, we represent a company called Surgex. They all manage their UPS technology differently. For the longest time, single sine wave or line interactive has been the technology, but there's 2 problems with that. One is it's not an online. So whenever power goes out, there's a little bit of a transfer time. That 2 to 5 seconds or milliseconds even can lock up devices. Also, that voltage is still fluctuating on the outputs of that device. So as your system is going from 108 to 132, that UPS is fluctuating as well. Something that has an online UPS technology built into it is actually the best way, because it's going to be locked in at 118 or 120 volts, and it's never going to drop below that. Even with an outage, there's 0 transfer time, and then you have a surge piece in line, which is going to keep you from going over. So it's kind of a 2-pronged approach. But Jeff, do you kind of care to submit any comments on that?
Absolutely. I agree 100% with what you said, and I have a few things to add. First of all, I probably get a weekly question from clients: should I do the FP&L meter protection thing? Okay, the answer is yes, do it. It's cheap. It's, what is it, $5 or $6 a month, and it comes along with I don't know, something like $5,000 or $10,000 insurance. But they install it at the meter. In my own case, they actually replaced the meter with a fancy new digital one. So I would have done that just to get the new meter, because my other one had a crack on it and I couldn't read it. But anyway, they come out at the meter, and that protects. That's what I call first stage protection. So that's everything in the house, small appliances, as well as large appliances, air conditioners and everything. And it is strictly for surge. Does nothing for sags, nothing for brownouts. Second layer of protection is a power conditioner, like what was mentioned in here. It could be Panamax, Furman, whatever like that. But again, surge only, and those are a little bit more sensitive. They have thresholds on them of what they consider, because some of them sacrifice, right? Where they use MOSFET, and they will disconnect from the power and shut off, go into protect mode, which can be a problem in and of itself. Clients call and like, yeah, it's doing its job, everything's shut off to protect itself. But I would do the second stage is in your equipment rack, or wherever your equipment is at, have a second level for your critical load stuff separately. And then third would be what you mentioned there, which is the pure online UPS. I think Surgex is probably the best one I've seen out there. Panamax has a really good one as well. Surgex tend to be larger, hold more loads. So you would definitely want 3 levels of protection. And so that's definitely how I would go through that. Is now the second thing I was going to mention is, when it comes to surges, would you believe that the majority of the problems we have do not come from FP&L? That is definitely a thing, okay? But we see surges come in through coax from, say, Comcast, right? I've also seen surges come in through the pool equipment, where there's a static lightning charge. It's picked up by the large body of water, and it comes through the pool equipment, and comes in that way. So it didn't come through the meter, right? So that's what I'm saying is a lot of these things boil down to analyzing all of the ways that power can get interrupted with from the outside in. And then you touched on another important point, Jason, which is the products that you use in your house generate noise. When an air conditioner kicks on and that motor engages in, that will suck. There's inrush current. It'll create a sag. And if you don't have the right service coming in, or maybe your equipment is getting old, that sag could actually create the problem within the enemy within, right? It's right within you. The UPS will beep and go over like, oh, geez, every time the air conditioning goes on, I hear a beep from my UPS. Yeah, guess what? That air conditioner probably needs service. It's probably got a big, massive inrush that's going on, and it's just sucking down. I've actually found one client had this, and we found a loose lug. Took us like 3 months to track this down, but we finally found a loose lug in the service connection in the street under a manhole, and it wasn't tightened down all the way. And it worked most of the time, but when something would kick on heavy like that, refrigerator, air conditioner, it would create enough of a sag that it would send all of our UPSs beeping, and the client would see their lights flicker all the time. And then FP&L, of course, they didn't do anything about that. So there's a whole study around this, and if you want clean power, it is a lot bigger than just one topic. You have to consider multiple stages. So
yeah, we had a project in Miami that was a new construction, and the client consistently had AV problems, and we put the Surgex Envision piece in which it did all the monitoring, and it came back with a lot of issues. So the issues were outside of the range that FP&L delivers, and the electrician refused to troubleshoot it. And we pretty much said there's a neutral to ground problem. We got another electrician who was actually an AV integrator to go in and check it out, and he goes, "Oh, new construction, I guarantee you connections in the panel are loose." So he went into the electrical panel, tightened down all the connections, and it stabilized the house.
Right. Now, you'll notice there's a new code in South Florida, and I don't know if it's everywhere, but it's definitely here. We used to have GFI, right, at ground fault interrupt, and that was, oh, it's near a sink, it's near a body of water, it's, in the bathroom, whatever. Now we have these, way more sensitive that are what's the term? It's not GFI. It's the name escapes me, but it's more of a hair trigger. It measures the voltage between ground and neutral, and if it is off by a little bit, it pops it. And you have to do that on every outlet now. And so we see a lot of these nuisance trips that caught, like if you have one behind a refrigerator in the garage, guarantee you that refrigerator turned on and that power outlet goes and there's nothing wrong. You have to take it out, pass inspection, and then replace it. But it's also a symptom of exactly what you're describing there. If there is something wrong, loose or whatever, you'll have that little microvolt difference and it'll pop those guys. The ACFI, I forget what they're called, but it's a lot more sensitive than the GFIs, the ground fault. The reason why I bring that up is this concept of ISO ground. Have you dealt with ISO grounds at all?
I have not.
ISO
transformers, but not ISO grounds.
ISO ground. Okay. So if you have the opportunity to do a critical load, and I showed you on that little diagram I brought up for that project in the MDU, we ran a fourth wire. So normally you have the all wire Romex is 3, right? You have your copper, you have the copper chassis ground, but then you have 3 shielded connectors, a white, a black, and a green, right? Hot, neutral, ground. The ISO ground is a fourth wire. And what that creates, and sometimes they call it a technical ground, that's the other term for it. Surgex promotes this particular thing in their load centers. And so what you do is you run an extra wire and you keep the ground plane the same for all your AV equipment. That way, when those things fluctuate and come on and off your air conditioners, they don't interrupt the ground plane that all your AV is on. And it keeps them from tripping, and it keeps them all happy and solid. because that other ground, that is what every other thing in the entire house, building, whatever, is using. You know, when they turn on, all that power goes on that. So this is isolated, and then you ground your racks, you ground your equipment. Then when lightning comes in, it can take the other ground to earth. Our ground is floating. It's out there. It's not a path to send the surge through if you did happen to get hit by lightning. So I highly recommend putting that in. You'll see it in every single hospital. The outlet has that little triangle by it, and that's called an isoground outlet. They're typically orange, though I found some manufacturers make white ones yesterday, so I was pretty happy about that because orange ones are obviously ugly, right? But so if you could do a critical load panel and you can talk to an electrician that would run the extra cable, that is the safest way to do it. Then you're all set up for doing a battery backup down the road. You know, it's all there. So any other questions come in? No, I didn't see anything else from the chat session. We've got a couple more minutes on there.
Did you have any questions, or Jeff, did you have any questions on the presentation? I know, we discussed the race point solution a few weeks ago, but I don't think we went through a presentation. So was there anything that popped up that you had questions on?
Well, not really, because I got with the CEO of RacePoint and he ran through everything. That is definitely big boy stuff. That's a tier above what we normally see. And I also love the fact that Savant in particular has embraced this as a control system, and their touch panels have all of this rich information on it. So if you really wanted to know what was going on power in your house, there's actually a control system that can read the data live and plot it in these really cool, like, looks like a dashboard kind of a setup. I haven't seen anybody else take data like that, mine it, and display it in real time. I was really fascinated by the vision of Savant in general and RacePoint, which it's the same founder for both companies.
Yep.
Rosewater is the other company that we work with, but it's smaller scale. It's 20 kilowatt. That's what we have in the building.
I think it comes down to the client's needs. I can tell you, I've had probably between a dozen and 20 inquiries of people that said, oh yeah, I want to go off the grid. And then even when they see the price, they're a little shocked at even with all the discounts and incentives. But at least it starts the conversation of, okay, you thought you wanted to be off the grid, but there's other ways that we can still augment things and give you clean, stable power. And then you can go through this design path. And there are a lot of different solutions out there.
Yeah, and I would say the other thing is off the grid doesn't mean necessarily renewables. Right? You could have solar. You don't have to have solar. All of the battery systems that we've put in that are grid aware, right, that actually do work when the power is off, right, those, all of them except our building, we have solar here. None of the other ones, HOAs, I just got a new roof, it looks ugly. I mean, blah, blah. There's all kinds of reasons not to do solar. I haven't heard anyone want to put a windmill in their backyard. So, wind isn't really practical for us here. Well, so you can have clean energy and be disconnected from the grid because you've got a battery between you and the grid. And that solves your problems. And then you use a generator if you need long-term outages, like days, right? A good battery system should be able to do, 8 to 10 hours, right? You can absolutely do that. We achieve those levels without renewables. And that, frankly, is 99% of the problems down here because it's the micro outages. If you're going to, the thing I like about, and I've lived in California and I've lived here, the thing I like about living here is when a hurricane's coming, we have notice. And most of our higher end clients, they will pack up and leave Dodge and shut down the house, and we're turning breakers off and we're going into storm mode and we're leaving, right? Where you get into the problem is that in between the everyday, it could be a sunny day, it could be a stormy day, whatever, but power's flickering and things are going, that's your biggest issue, and that's what's going to cause all your problems. The surges are, hey, that happens. The SAGs are every single day. The long-term outages are really when we have bad storms or somebody runs a truck into a power line and it's down, because of that.
Yep. There was a question that came in about are the microgrids US only? So I can't say for sure. I know there's been some projects outside the US. I don't know if those were 220 or over in Europe. I would say, reach out to the team at Boca Tech if you have a project where you want to inquire and we can work together on that. You can also reach out to RacePoint directly. But I don't know of any limitations to that. I just haven't personally worked on
Yeah.
projects with that requirement.
We have three-phase power, 208 Y phase here, which is a little unusual because it's commercial. But yeah, we can absolutely do 220 volt. We can do 208 and three phase with the solutions that like I have in this building. So, but yeah, we would need to look at the plans and run it by the electrical engineers.
Yep.
So, all right, we're right at noon o'clock here, 12 o'clock. So I appreciate everybody hanging on and listening to this. This is a passion project of mine, and Jason, I'm so happy that you're engaged in this as well. You're my go-to guy for power stuff. So I appreciate your time. I loved the presentation, and I look forward to the next one.
Great. Well, thanks again for inviting me. I look forward to the wrap up.